Okay, welcome back. We're talking about the user account control. So, if you're an ordinary user on a machine and you do not have administrator rights, well, the prompt will come up and basically say, "I see that you are not an administrator. Go find one and allow them to log in, and then you'll be able to do this." If you are an administrator, it says, "I see you are an administrator, but prove it to me that you really want to do this by giving your permissions one more time." Okay, so that's good because I don't want these people to have more power than they have. There's an example that I always use. Let's say since I'm a software author, let's say I'm logged in as an administrator and I'm writing this application and everything works great, and then I send it out to the people and they try it and says, "Man, this thing don't work at all." "Oh, really? It worked great for me." "Well, yeah, because I had 10 times the permissions that guy has. So, yeah, I need to be able to drop down to an ordinary user while I'm doing this to see what they see, to see what permissions they have rather than the permissions that I have." Okay. On page 393, they're talking about the installation and startup. So, in the old days, operating systems were sold on, CD-ROMs or DVDs. For a brief period of time, you could go get ISO files and create your own CDs. And now, basically, you download stuff off the internet or you put it on a thumb drive. So a USB-based flash drive is the most practical way people use to install operating systems. Doesn't matter. It's really the same files. It's just whether it was on a CD, a DVD, or a USB flash, or an ISO file. Doesn't matter. It's all just the same stuff. So you have to be able to boot the machine up with this. So you stick the flash drive in and give the machine a boot. And if it's configured correctly, then it'll fire up and say, "Hey, would you like to install this operating system?" Cool. So how does all that work? Well, when you first turn the power on your computer, there's some built-in stuff that happens. So the machine wakes up from its nap and goes, "Oh, what's going on? Wait a minute. What's going on? Oh, wait, I see I have a hard drive down there. Yeah, and it has a thing called a master boot record, and I bet I'm supposed to load the instructions at that location, and then I'll go back to sleep." That's essentially what it was. The BIOS, basic input operating system. Machine wakes up, it looks to see where its operating system is, almost always going to be on a hard drive. It finds it and then launches that and then says, "Okay, it's yours from now on, I'm going to go away." So that's how it boots up. So the master boot record typically instructs the machine. Now, I know people that have multiple operating systems installed on their machine. So when their machine boots up, instead of saying, "Well, let me just go find my operating system. Ah, there it is. I'm going to load that." It says, "Let me go find my operating system." And he goes, "Oh, man, I see more than one. Well, what do you want me to do?" So a little prompt will pop up on the screen and says, "Here's the listed operating systems. Which one do you want?" And so I'll take that one. And then it'll launch that application. Okay. On page 394, they talk about how would you scale up an operation. If I've got a computer and it's not doing everything I want to do, and I want to get another one, and I want to scale up, I want to do more, how could you do that? Well, they have two different techniques to talk about. One is called virtual machines, where I go get me a giant server and actually put like 3 or 4 operating systems on it simultaneously. Another one is called warehouse scale computers. And to tell you the truth, I don't see that term used very often. There's an awful lot of things called cluster computers and things like that mean the same thing. So the concept is great, just the terminology is a little off. So before we even get into that discussion, we need to talk about big data. This may be a term you've heard. So big data is basically, I've got a scenario where I'm collecting so much data that the traditional techniques for, sifting through the data and asking questions and sorting just don't work for me. So for example, in the book they talk about the how many terabytes of data that are posted on Facebook in a day. I mean, Facebook has just huge quantities of data. Well, think about, the U.S. Census Bureau, where they have, a record essentially on every household. So they got, a couple million households, and all this data. And if I was to go in there and say, like an Excel spreadsheet, I want to sort by column B, the data is just too big. It can't do that. So I need another technique to deal with big data. Just the normal routines that you're familiar with on querying and sorting and things of that nature, things that are done in databases. If you have huge quantities of data, that just flat don't work. Okay, so big data. It's really about, I got too much data that I can't use traditional database things. And Facebook has 500 terabytes of data per day. 500 terabytes a day. Can you imagine? Oh, wait. I want to build a database that can sort through all the photographs that are installed on Facebook. If it's 500 terabytes per day, how much disk space am I going to need to be able to do that? That's just not going to work. I need a different way. So they describe the 5 V's, and this is kind of a cool term. Anyway, they talk about the volume of the data. Just how big is big data? The velocity. How fast does it change? Is it static? I mean, for example, the Census Bureau is huge, but they only go out every couple of years and make tweaks. So it's not like that data is changing a lot. Unlike Facebook, where it changes a tremendous amount. The variety of data, is it all text? Is it all numbers? Or again, like Facebook, is it pictures and movies and text and all sorts of other things? So the type of data. The veracity of the data. I mean, they're talking about the concept of, the importance of the data and, how it, well, the value. Let's just directly to the value. What is the value of the data? Is it highly valuable? Is it not? So, yes, those are the 5 V's you have to deal with. So, one more time, the relational database approach, something we talk about in some of our database classes, really just not designed for that kind of thing. If your data is very well structured, yeah, sure, you can use the relational database approach. But if your data is not structured or it's just way too big, then I can't. So we're not going to go down that path on how to do big data. We're just describing the problems with big data and why you can't use the traditional approaches. After that, we drop it and move on to the next topic. Hey, okay. So the next topic is virtual machines. So if I want, let's say for example, I've got 2 old servers that are kind of aging and I want to replace them. One is, let's say, a SQL server for doing database, and one is a web server. And they're getting kind of old, and it's been 3 or 4 years, and it's time to replace them. So do I go out and buy brand new servers and then put SQL Server install on one and web install on the other? Is that the way I do this? Probably not. What I would probably do is I would probably invest in one big server and basically carve up the server into individual machines. So I actually have 2 operating systems in the machine simultaneously. Now this sounds a little weird, and the way it works is, if I can get to that picture, give me just a second, is that I have an honest-to-God real computer with a host operating system on it, and then I broke this thing up into a SQL server and a Visual Studio server and some other server, and I actually install, in this case, let's just say I'm installing Windows 2012 on that machine, Windows 8 on that machine, and Ubuntu Linux on the other machine. I'm actually installing 3 additional operating systems on the same computer. And so the host operating system plus these 3 extra are all running simultaneously. Yeah. So I can get some economies of scale. So for example, in the scenario I just described, where I have SQL Server and a web server, perhaps their load isn't always the same. And therefore, if I put them together in one giant computer and separated them out, then I can get some economies of scale. I could buy bigger, more RAM and more CPU, and then I could divvy it up among the two. I can go to the web guy and say, well, it doesn't look like you're doing much work. Why don't I just steal a few CPUs from you and add them to this other guy who is using more work. So virtual machines provide you an opportunity of breaking things up. Now this machine that you're looking at right this very second, this guy, this is a virtual machine. I'm using a product called VirtualBox, and so this is a virtual machine you're looking at. I do not have on my main machine at my house. I'm running Windows 10. This is Windows 7. And how did I do that? Well, because I'm running two operating systems simultaneously. I'm doing virtual machines. Okay. So back to how this thing works. There's a host operating system and a guest operating system. So in this case, my host is Windows 10. My guest is Windows 7. Cool. All right. I can get more utilization out of the same hardware. That's kind of a cool part about this. If I have multiple virtual machines, I can kind of just borrow from each other, so to speak, whenever I need more RAM or more CPU, because it's not a physical CPU anymore. It's fake. And it's not physical RAM anymore. It's all just kind of faked out. The cool part about this is I can kind of ramp up and ramp down as I need more resources. That's the cool part. So each one of these has a virtual CPU. This one could have 2 cores. This one could have 1 core. This could have 4 cores. You get to pick. Each one has virtual memory. Well, this one could have 2 gig of RAM. This could have 1 gig of RAM. This could have 4 gig of RAM. Virtual hard drives. Well, this one could have a 30 gig hard drive. This could have a 60 gig hard drive. It's your choices. And then the virtual devices are all the rest of the things like the mouse and the keyboard and camera and whatever else you got. So it makes it look like, as far as this operating system is concerned in this application doesn't have a clue whether or not it's running on real hardware or faked out virtualization hardware. It really can't tell, which is good. Okay, cool. I use it for creating a temporary environment. Let's say I'm working on something and I think it's going to be terrible. I really think it's going to blow things up. It's possible. Well, I'll just pop open another virtual machine here. I'll pop open a virtual machine and do whatever it is that's dangerous. Just let it happen. And if it blows up, I say, no big deal. I'll just wipe that one out and move on. I mean, it only took me a couple of minutes to build a virtual machine. And so if I blow it up, what the heck? I'm only out a couple of minutes. I use it a lot in testing and development. For example, I'm writing an application that requires my program to talk to another computer, but I don't have another computer. So I want to pretend like I've got a file server. So I create a virtual machine that acts like a file server, and I test the application back and forth. And when the application is done, I throw the virtual machine away because I'm done with it. Cool? All right. There are 2 different types of virtual machines. The one that I just described is called Type 2. So a Type 2 is one of those where it requires a host. In other words, you can't have, well, it requires this host operating system. Everything, the virtualization layer happens above the operating system. Okay, that kind of makes sense. And this is perfect for doing like desktop kinds of things, just normal word processing and things of that nature. And I use it for testing because they're pretty easy to put together. The other type is called a Type 1, where the virtualization layer actually is between the host computer and the operating system. It actually slips in right there between these two. And the Hyper-V can be configured, the Microsoft product. And there's a bunch of other types and brands of virtualization that fit right in there. But this is a good place to stop for the 15-minute mark. We'll pick this thing up again in just a few.